Okay, we are ready for alkenes, which are homologous series C and H2N. They are unsaturated. They at least have one double bond. Now, alkenes are much more reactive than alkanes. Why? There's two reasons for that, be able to justify. First reason is the double bond is less than twice the strength of a single bond. When you go to your data booklet, you will see the double bond is about 612 kilojoules per mole to break it or form it, versus a single bond, which is 348 kilojoules per mole. You should agree that 612 is not 2 times 348. It's rather smaller than that by 200 some kilojoules. Therefore, it's weaker. So the pi bond is weaker and you can attack it. The second reason is the fact that you have double bond or 4 electrons between the nuclei of carbons. That's a high electron region, and electrophiles, those species that like electrons, can attack it. Now, these typical reactions of electrophiles adding to the double bond and making it single bond saturations are known as addition reactions. So you usually have a double bond, and if you put a molecule next to it, which has two partners, X and Y, it goes through addition. The double bond opens, gets saturated, and your X and Y, whatever they are going to be added, X to one carbon, Y to other carbon, and it becomes an alkene. Alkene becomes alkene. So now I'm going to give you some addition reactions, and I'm going to use ethene as my starting material, so C2H4. The first category is addition of halogens or halogenation. So I'll take my ethene, show the structure, double bond, 4 hydrogens. Now I'm going to add a halogen such as Cl2, hydrogens, and this becomes saturated, and 1 chlorine is added to each of the carbon. Now name of this is 1,2-dichloroethane. Notice that the last name now becomes alkane because I have saturated, and this was ethene. So that's typical halogenation. Also, this is good to remember. A test for alkenes is we can add it to bromine and see what happens to color. If you add it to bromine, now bromine is reddish, brownish liquid. When you do that, the color of the red should disappear, becomes transparent or colorless. So when you do this, you will produce a product which is 1,2-dichloroethane, and it's colorless. So remember, this is a test for alkenes. The second typical reactions of addition, I'm going to call it hydrogenation. We are adding hydrogen in presence of nickel catalyst. Then again, this is important commercially because that's how you turn corn oil into margarine, a solid, because of the packing and van der Waals. So I add hydrogen gas with nickel catalyst or over nickel catalyst, and this becomes saturated. Ethene becomes ethane. So commercially, this is very important because you can saturate your oil into solid margarine. The third example I go after is hydration. Now there is a difference between hydration and hydrogenation. Remember that. In hydration, I'm going to add steam or water to it, and I'm going to make alcohol. Then again, commercially extremely important. That's how you make synthetic alcohol. So we add H2O, Usually you have a catalyst. In this case could be phosphoric acid or sulfuric acid, H2SO4, and you have heat. Now what you can imagine is H2O is like one part H, the other part is OH. So I add one H here to this carbon, and I add my OH to this carbon. So they are going to open this up and add to it. So the product will be an alcohol, which is in itself important starting material for other organic matters. This is ethanol, which you usually produce it by fermentation of fruits or corn. Then I go to the next slide and talk about more of addition reactions. The fourth one is just simply adding a hydrogen halide. So addition of hydrogen halide, such as hydrochloric acid. So I take my ethene one more time, and this time I add HCl or HBr to it. Let's go with HBr, and I will produce CH3, CH2Br, and this is bromoethane. The final addition reaction, which is really important, is known as addition polymerization. Now, polymer is one macro or giant molecule made from many monomers. So if you simply have ethene, bunch of ethene, and this is how you usually write your reaction, and N is a number. Usually N is like 40,000 of those monomers, or at least 10,000. You put it in a pressure cooker, sort of speak, a batch reaction. So you have high temperature, high pressure. At the end, you are going to have one molecule that you can inject it into a mold and have it as a plastic bottle or other objects that you want to make. And this is how we show at least one segment of that monomer. And this is polyethylene. Many of your bottles that you drink water in it is polyethylene. I'll give you two other variations. Your monomer could be a chloroethene. This is also very important in real life. When you make it into a monomer, you will produce PVC. PVC are those pipes that you will just carry water in it or play with it instead of copper pipes. So this is known as PVC or polyvinyl chloride. And the final example I like to go over is if you take tetrafluoroethene, you will produce something that commercially is known as Teflon, extremely unreactive, and you have it as the surfaces of your pan that you cook in it. So this Teflon is a trademark by DuPont, and it's highly unreactive. So typical reactions of alkenes.